Hey everyone, welcome back. Uh, Today we're going to be solving Leetcode 94 binary tree in order traversal. If you've seen my tree series, I've already solved this question, but I've solved this question using recursion. I've not used any loops as such. I've used only recursion and it's only function calling. But there's another way to solve this without using recursion, right? We can solve this without using recursion, and that's exactly what I'm going to be doing today. The reason I'm solving this problem again is because we need to know both the routes so that we understand how actually the stack is working in both of them. Right. In function calling, it's just the stack where each stack frame contains a function call, right? But whenever you're doing in a loop, you don't have the stack concept, right? Because it's just one function, and under that function you're writing the entire code. Now we can still utilize stack, but in a bit different way. That is the reason this problem is kind of interesting when you solve it in both the ways. Okay, so we're gonna be solving it using just loops and then stack. Okay, so basically, in order traversal, for the people who don't know what it is, it's basically traversing through a binary tree in this particular direction. That is, left, left, and then you reach the node and then you go to the right. This is how we'll be solving it. Okay, now we need to solve this using we can easily solve this using a recursion because each stack frame in recursion has your function call, right? So you have trace of the function, right? So whenever you exit, like whenever it hits the base condition, it will fall back to the function which it had initially called, right? So because of that, you can easily trace the call, and with that you can output your result. For example, if I'm going from left node to right, what I'll do is I will initially call the left. I'll call root.left. I'll call the same recursive call for root.left. Okay. Then once root.left returns me null, like once it reaches, let's say, this point, it returns me null. What I'm gonna do is I'm gonna print what is the root.value, and then I'm going towards the root.right. Right, and since the root.left function has been called, that function would be in the stack frame, right? So we don't have to necessarily trace it or store it anywhere. But when you're using a loop, it's just that one function you're calling, and inside that function you have a loop, and that is where you have to write the logic. So we need a path, or we need something, a data structure, to trace all those nodes so that we can get it back, right? Because if you think about this node is nothing but, ideally there's nothing but a linked list, but divided into three parts: the left one, value, and the right one, right? So the thing is, whenever, let's say that we are over here at 30, okay, we are over here at 30, okay, there is no way for us to come back to 77. Okay, without tracing it, there's no way for us to come back to 77, because it'll be very, very, very complicated, and I don't think we'll be able to do it. That's the reason we need to trace those calls, and we'll be doing it exactly the same on how it's done while we perform recursion of this. Okay, so let's begin. Let's go through it one by one, and then let's code it out. Okay, I'm going to be going through this for the other two traversal as well in depth for search, that is post order and pre-order. This video is for Inorder. Okay, so now let's say that I'm at the root node over here. Okay, now what I have to do is I have to move towards the left. That is, I have to move in this direction, right? Now I reach 16k. Okay, so root.left is 16k, the value is not null. So what I do is, initially I have 77k which is pushed into the stack. Okay, then what I do is, current value is not null, right? So I have to push 16k also into the stack. Okay, wait, 77k. What is 77k, you ask? 77k is the address, 16k is the address. The reason I've kept it like this is so that the same as the value is so that it's easier for understanding. So at 16k you have 16, and then at 16k you have address of these two. That's what it means. Okay, now it's 77k. Okay, now I go towards the left. The current dot value is not, current is not null. So what I do is I put 16k. I go towards the left again. Now what I do is I go towards the left again. That is 13k. The value is not null, so I put it in my stack. Okay. Now from 13k I go towards the left. Okay. This value is supposedly null, right? So I cannot go further. So when my current dot value is null, what do I have to do? What do I do in my recursive call? I return it back to the call which the parent call, the call which made that recursive call. I return back. Then my step 1 would be over. It will go to my step 2. Step 2 is what? It will have to print the value. There are 3 steps, right? You're going towards the left node, then you're doing some operation on the right node, then you're going to then you're doing some operation on the node itself, then you're going towards the right node. What is that operation that we're doing? We're just printing the node over here. Okay, we're just printing the node of node dot value. Yeah. The operation that we're performing is printing the node dot value. Okay, so now what we'll have to do is we'll have to print the value. That is the next step. Okay, that's exactly what we're following during our recursive call. If you don't have the context of what I'm saying, please watch the video for Inorder Traversal recursion video of mine, where I've done the stack trace of the entire call. Okay, and that's exactly what we'll be doing it over here, but it's just in a different way because we don't have the recursive function. Okay, so now if you see, once my current value in the recursive call hits null, what do? I come back and I go to the second step. I'll do the same thing. Okay, now if you see, my current dot value is null, right? So my current value is null, right? Because when I put in 13k, what I'm doing, I'm calling 13k dot left, which is null. So my current is set to null. What do I do when it's null? What do I have to do? I have to print 13k. Okay, so for printing 13k, what do I have to do? I have to take the value, let's just take current value only, and then it will be nothing but stack dot pop. Okay, so this I get the 13. Current value will now be set to 13. Now what do I have to do? I have to print 13. So what I'm gonna do, SOPLN of 13. Perfect. So now I've removed 13, okay, from the stack. Okay, now what I'll do is I will have to go towards the right. That is the next step. So what I'll do is I'll say current dot right. Okay, so if current is equal to null, this is my code. This is how my code will look like. So my output is currently 13 now. Okay, now what will happen? Current dot right. If you see current dot right, this value is also null, right? So my current will be null again. So what will I do? I'll stack dot pop 16k, because that is our next output. So I've come towards the left. Okay, now I've come towards the left. Now I come more towards the left. Here I've reached null. So left is done. Now I'll be printing n. Then I'll go towards the right. This is also null. So what I'll go do is my left part is done. I'll go here. For this left part is done. Then I'll print 16. Then I'll go towards the right. Right? Makes sense. So now what I'll do is I've reached 16k. Then what I'll do is I'll have to go towards the right. Right? Stack dot pop 16k. Now my current is stack dot pop 16k is done. I'm gonna print 16k, and then current is current dot right. Now what is current dot right? Current dot right is 30k. I put 30k into the stack. Because it's not null, I put 30k. Now what I'll do is when stack is not null, okay, else when stack is not null, what I'll be doing is I'll just be saying current equals to current dot left. Before that, we'll have to push it towards the stack. That is stack dot push of what? Stack dot push of current. Okay, now this will be my else case, right? So now what I'll do is I put in 30k. So now from 30k I have to go towards the left, right? So what I'll be doing, I'll be going towards the left. That is my stack dot push 30k. I push 30k. Now I'll be going towards the left, right? So for going towards the left, I'll go to 22k, this part, right? So what I'll do is I'll put in 22k, and after putting 22k, my current will be 22k dot left. Okay, do you see any left? No, there's no left. So what I'll do is it will go to stack dot pop. It'll pop out 22k. It'll pop out 22k, and then I'll print it. Perfect. Then I'll do current dot left. So current is stack dot pop, which means current is at 22k, right? Current is at 22k. Current is 22k. Now what I'll do is current is current dot right. What is current dot right? Left is null, right is also null. Okay, so now what I'll do is it will stack dot pop, that is I'll go to the one which is on top, that is 30k. It will pop it, and then my current is now currently pointing at 30k. Okay, now I'm going to print 30k, which I've already done. Now I'm going to current dot right. What is 30 dot right? It is 58, right? Now what I'll have to do is I have 58, so my current value is 58. What I do is I put 58 in the stack, then I put 58k in the stack. Then what I do is I try to go towards the left. Left is null, so what I'll do is, since it's null, it'll come here, it'll pop out 58k. Okay, then what I'll do is current dot right. Is there any value towards the right? No, there's no value towards the right as well. So what will I do? I'll have to pop out the one in the stack. Okay, I'll pop out 77k. Okay, now current dot right is 89, so I'll put in 89k in the stack again. Okay, now after I put in 89k, my current will always be current value dot left, right? So 89k dot left is nothing but 73k. I'll put in 73k. Okay, now what I'll do is I'll put in 73k. Now I'll do current dot left, which is nothing but null. So when the value is null, what I'll do is I'll have to pop out 73k. The first step is over. Then I'll have to assign current dot right. That is nothing but 73k dot right. That is nothing but 78k. The value is there. I'll put in 78k now. Okay, looks good. I put 78k now. Now what do I have to do? I have to go towards the, this is null. Okay, I have to go towards the left. This is also null now, right? Right is also null. So since both of them are null, what will happen is since 78k, what I'll do is I'll pop out 78k, and my current will be 78k. Right, I'm assigning my current to be stack dot pop. That is nothing but 78k. Now I take out 78k, and then I SOPL in it. This is the output that I'm doing. Then what I'm doing is current dot right. That is 78k dot right. What is 78k dot right? It's null. So then what I do? Again the value is null. So then I come over here. Then what I do is I take 89k. I'm gonna pop it out, and then my current will be pointing at 89k. My current will be pointing at 89k. Now I'm at 89k. What will I do? 89k dot left is over. That is dot left is over. Now I have to go towards the right. So I do 89k dot right, which is again nothing but null. Since this is null, what's gonna happen? What are we doing when it's null? We're doing current equals to stack dot pop. But if you see, my stack is empty. My stack equals to empty. My stack is empty, so I can't do pop. Okay, and my current is null. Okay, and my stack is empty, which means that all the elements have come out, right? So I can't perform any more operation. So that will be our breaking case. So when current is null is when I'm popping it out from the stack, right? So if my current is null itself and the stack is empty, there's no point of going inside the function. That'll be my breaking case. When my current equals to null and my stack size is equals to empty. Stack dot size is 0. That is when I break. Breaking condition. Perfect. This is exactly how it's working without the recursive calls. Okay, let's code it up and let's see how it works. Okay. Let me change the okay. Okay, I have to return a list of integer, right? I'm gonna have a stack. I'm gonna call it as integer, and then my stack is to okay. So what I'll do is I'll create a shallow copy of my, because I don't want to lose the reference of root node, because whenever I travel from the root node, there's no way for me to go back, so I have to take a reference. So current equals to root. Okay, while current not equal to null, wait, and my stack wait, I'm just thinking, does it have to be an OR condition or does it have to be an AND condition? If AND condition, if one of the condition fails, also it won't go in. Now if either of the condition is okay, when both of the conditions are false is when it won't go, right? Yes, or it won't be AND. Okay, and my stack dot size equal to 0. This will be my breaking condition. Okay, now what I'm doing is, if current not equal to null, what I'm doing is current stack dot push be my stack dot push my current value, and I do current dot left, right? Because initially I have to, if you see, look at the scratch pad, initially I have to push the value of the element into the stack, only then I can move towards the left. Okay, I can't move towards the left and then do it, right? Perfect. Now current dot left, else, so now what will happen is, if it's equal to null, then what do I have to do? My current equals to my stack dot pop. Now I popped it. Now what I do is I would have a list. In our case we printed it, but the operation here is different. So I'll have a list of integer and I call it final list equals to new array list. Okay, no. So my stack dot pop. Now my final list is nothing but stack dot pop, right? My final list would be I popped out the value, so this will not and will be current dot value. Wait, it's value, right? Current dot value. Okay, now what I'll have to do, I'll have to go towards the right. So now my current equals to current dot write. Perfect. Now what will I have to do? I'll just have to return my answer. Uh, Return final. Perfect. Let's just run it and see how it works. Current equals to incompatible types. T-node cannot be converted to integer. But okay, but current is a tree node only, right? Equals to root. Oh, okay. Okay, I made a mistake. It'll be of type tree. Because what am I storing in my stack? I'm storing the address, not the value. So if you see over here also, we were storing and popping out the addresses, right? If you see over here, we were storing and popping out the addresses in the output also. No, I mean we were printing out the value for sure. But what I'm saying is when I was showing you the popping, I was popping the current address and then I'm printing the value of that, which is nothing but 13 in our case, the same as the address. Right, just for our visual understanding, I took it as the same of the address, but it may or may not be the same. Right? Most of the cases it won't be. So yeah, what will your stack store? It will store your address of the left particular node. Okay, and it will print the value at that address. Okay, perfect. Let's submit it. Perfect. I hope you understood the solution. I would suggest you to do the same thing. Trace it, go through the stack trace, and then understand how it's stored in the stack, how it's popped from the stack, and how that element is accessed. Okay. Thank you so much for watching.